Hello, in this video, let's talk about the properties of logarithms. Now, logarithms are inverses of exponential function, which means that there are some similarities between the properties of exponents and the properties of logs. So let's look at all the properties of exponents and compare them to the properties of logs to see the similarities. So the first property that we have in exponents is the one with addition. So if we have the same base and we're multiplying, then we're adding the exponents. So 3 to the 2 times 3 to the 5 is going to be 7 threes, so we add the powers. No matter what the bases are, the expressions in red, these are the general formula. So let's zoom in a little and scoot back over. So if we have the same base and we're multiplying, then we add the exponents. For the logarithms, if we have one base and we're multiplying something inside, we can split it up into two logarithms using the same plus that we had with exponents. With the division, when we divide with the same base, then we subtract the powers. And no matter what the base is, if it's the same, the general rule is we simply minus the powers. Whether they are whole numbers, fractions, negative, positive, no matter. As long as the base is the same, we minus them. For the logarithms, if we have a division inside, we split them up using the minus, the same minus that we had with exponents. And the general rule is if we have log of any base and there is a division inside, we split it up, we expand it using the minus. For the exponents now, suppose we have 3 to the 2 and then the whole thing 4 times. That means we're really using 3 to the 2 4 times, so we multiply the powers and we get the 8. And that works no matter what the base is. If we have one base and we have two different exponents, we multiply them out. With logs, if we have something to the exponent, we move that exponent to the front. So if we have m to the power n, the n becomes multiplied of the log. For the exponents, anything to the power 1 is itself. So whether it's 3 to the 1 or b to the 1, it stays whatever it was. For the logs, if the base matches what's inside, that's the same situation as asking 3 to what power makes 3? Well, the answer is 1. So log of b to what power makes b? Well, the answer is 1. And then also to the 0. 3, anything to the 0 is 1. B to the 0 is 1. Any base to the 0 is 1. And for the logs, if you have log of base, any base of 1, that means the answer is 0. Because that's like asking b to what power will make 1? Well, b to the 0 power makes 1. And that's why a log b of 1 is 0. And the last rule is combines exponents and logs, because 3 to the power is actually exponential, but then the power itself is log. And so if the exponent and the base match, then the two cancel each other off, because the exponent and the log are inverses of each other. They cancel each other off and give you just whatever was inside. So b of log b of m, everything will cancel off, leaving just the m. Oftentimes when we have in our homework and quizzes, we are asked two questions. First is expand. We have one logarithm with something inside and we're asked to expand it all the way. So we will be using the formulas for the logs and looking for each one of these situations and expanding them using the right hand side. So let's do that. So here is our example, and we have base 5. So the division means minus, but before, on the top, we have log base 5 of everything, 5x to the 2, y to the 3, minus because when we are dividing, we subtract the top from the bottom, keeping the same base. So the base used to be 5, the base used to be 5, and so we keep the same base. minus log of the same base, z to the 5. Now we use the other rules with the exponent. If we have anything to the power, we move that power to the front. And that's what happens next. So before we do that, we also have a multiplication. We have two instances with times. And in our formula, the times turns to plus. Let's scroll back over. So here is the formula. With the times, it expands as a plus with the same base. So let's expand that piece. That makes log base 5 of 5 plus, because we have a multiplication, log base 5 of x to the 2, again, plus log base 5 of y to the 3 minus log base 5 of z to the 5. And at that point, we use the property of the exponents and we'll move all the exponents to the front, and we'll see what that gets us. So we have log base 5 of 5 plus, now the 2 moves up, we get 2 log base 5 of x. The 3 moves up, we get plus 3 log 5 of y. The 5 moves up, 5 log base 5 of z. And that's almost the finished answer. The only thing left to do is, here we notice we have the same base as what's inside, and that equals to 1 according to our formula. So we rewrite the whole answer as 1 plus 2 log 5x plus 3 log base 5y minus 5 log base 5 of z. And that is our final answer to expanding our original logarithm. So that's the answer to expand. The other half of the question is, of course, go the other way. So if you already have it in expanded form, could you go back and put it as 1? So that's the second half of the question, and let's do that one also. Now, when we do that second half, we reverse all the steps we just did. So the first thing we do is we move all the exponents back up. So move the exponents back where they came from. And then we use the pluses and the minuses to compress it into one log. But we have to be sure that all the bases are the same. If the bases are different, that would be like trying to combine here with exponents 3 to the 2 and 4 to the 5. If these bases were different, there will be no addition of exponents because we're dealing with two different things. Same with logs. If these two bases are different, we are not going to be combining them. They will remain two different logarithms. So let's do it with our example and see what we get. First step, moving all the exponents back up. So we get log base 2 x to the power 1/3 minus log base 2 y to the power 2/3 minus log base 2 z to the 8. Now we use the minuses to combine. Minus is a division, so we have log base 2 just once, and then we have x to the 1/3. Minus is a division by y to the 2/3, and then z to the 8th. And that could be the answer. If our question did not ask to change these exponents into the radicals or the roots, then we're done. That's the end. But if we ask to change it, then we have to remember that the bottom number is the root number and the top number is the power. So we can rewrite it as log base 2. And then here we have cube root of x to the 1 divided by cube root of y to the 2 times z to the 8. And that is most often the form that is expected on the homework and on the test. And that is the general overview of what properties of logarithms look like and how they compare to the exponents. And we can use those properties to solve equations and to do many other things. And that's it for this video. If you have any questions, please leave a comment, and thanks for your time. Take care.